Hi, today's video going to be about population genetics, and here is a problem. Consider a locus with alleles dominant A and recessive allele A in a large randomly mating population under the influence of mutation. If the mutation rate of the dominant allele into recessive allele is 6 multiplied by 10 raised minus 5, and the back mutation rate to dominant allele is 7 multiplied by 10 raised minus 7, and if q equals to 0.9 in generation n, what would it be one generation later only under the influence of mutation? So if you know how to solve this problem, you may stop video here, try to solve this problem on your own, and when you would be ready you can run video again and you can compare your answer with my answer and explanation. So actually those of you who is very good at mathematics can solve this problem probably without even extensive knowledge of genetics. So I always recommend to try to do it on your own first. And for those of you who don't know how to approach this problem, here's my explanation. So first of all, I want to tell you that here we have forward mutation and backward mutation, and also we have current state. So what is the current state? First of all, we have Q here, and that stands for the recessive allele. So the total balance and number of alleles in the gene pool can be expressed as P plus Q and would equal to 1. So if we know that Q is 0.9, and this is going to be a frequency of this allele, so this is going to be 0.9, and this is going to be a frequency of the recessive allele A. So that means that frequency of the dominant allele A would be 0.9. Oh, sorry, 0.1. So together this would give us 1. So we have two types of alleles, dominant and recessive. So let's now move to the second step, and in order to solve our problem, let me first write down the formula, and here would be the formula. So current state would be Qn, and if we are looking what's going on, how allelic frequencies would change in the next generation, so we would put here n plus 1, because our question is what would be allelic frequency one generation later. So, and this is going to be a frequency of the allele, recessive allele A. So here on the right side we would have once again frequency in the current generation of this allele. So this is going to be Qn, and N stands for the current generation, and Q stands for the recessive allele A, plus forward mutation, and this is would be U. So U stands for the forward mutation, and V stands for the backward mutation rate. So here would be U multiplied by P, so multiplied by P in current generation, minus V Q in current generation. So this is going to be our formula, and solution going to be relatively easy. Once again, U stands for the forward mutation, and V stands for the backward mutation. And according to our problem, forward mutation would be a mutation of the dominant allele into recessive allele, and this is going to be a rate. So this is going to be mutation of the dominant allele A into recessive allele A. And here we would have mutation of the recessive allele into dominant allele, and here is going to be a rate. So this is going to be backward mutation. So recessive allele into dominant allele. So as you see, now we can use our numbers for this problem. So here forward mutation rate is 6 multiplied by 10 raised minus 5, and backward mutation rate would be 7 multiplied by 10 raised minus 7. So what we can tell here, instantly we can tell that here we would have surplus of the recessive allele in the next generation, because we would have much more dominant allele converted into recessive than recessive allele converted into the dominant allele, because this number is much smaller, about 100 times smaller than this number. So what we also can do with the next step, we just can convert these numbers into decimal numbers. So the frequency of the recessive allele A in the next generation, n plus 1, would equal to frequency of the recessive allele A, and this is going to be frequency. So this is going to be 0.9, and n stands in the current generation. So as you see, this is frequency of this allele in the current generation, plus and this is going to be U stands for the rate of mutation of the dominant allele into recessive, and this is going to be a rate, so we can convert it into the decimal number. So this is going to be 0.00006, and multiply it by frequency of the allele, dominant allele A, and this is going to be 0.1. So multiplied by 0.1 minus, and here V stands for the rate of the backward mutation of the recessive allele into the dominant allele, and here is the rate. We can also express it as a decimal number, so this is going to be 0.0000007 multiplied by Q, and Q stands for the recessive allele A, and this is going to be, the frequency would be 0.9, so Qn, and this means in the current generation. So now we just have to do calculations. If it would be helpful for you, we can rearrange or organize our formula like this. So frequency of the recessive allele A in the next generation would be frequency in the current generation plus frequency or number that would be converted dominant allele into the recessive allele, minus number of mutations that convert recessive allele into the dominant allele. And as you see, this number is much smaller, so we can say that in the next generation we would have more recessive allele A than dominant allele. So this number would increase, and number of the dominant alleles in this gene pool would decrease. So let's see what we have here. So if we multiply this number by 0.1, frequency of the dominant allele A, so this is going to be a frequency of the dominant allele A, and this is going to be rate of the forward mutation of the dominant allele into recessive allele. And this is going to be current frequency of the recessive allele A. So this number would be a frequency of the backward mutation of the recessive allele A into the dominant allele, and 0.9 stands for the frequency of the allele recessive allele A. So one more step, Q n plus 1 would equal to 0.9 plus 0.000006 minus 0.00000063, and so this is going to be forward mutation, and this is going to be backward mutation. So as you see, backward mutation is much smaller number than forward mutation. So as you see, at the end we would have more recessive alleles due to mutations that we start with. So our final answer would be Q in the next generation, and Q stands for the recessive allele A, would equal to 0.900000537, and this is going to be this number, going to be difference between this number and this, so this number minus this number plus current frequency of the recessive allele A. So this is going to be frequency of the recessive allele A in the next generation. And as you see, we would have in next generation more recessive allele A than we start with, and this is what we start with, were 0.9, and due to forward mutation of the dominant allele into the recessive allele A, in the next generation we would have more recessive alleles, and this is going to be frequency. And as you see, we can predict that after a certain number of generation we would completely lose this dominant allele A, and we call such situation that recessive allele A become fixed. So we would have only one allele for this locus, and we wouldn't have dominant allele at all, except a very small number, because backward mutation still would happen, but such situation we would call that recessive allele A would be fixed. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. Thumbs up if you like this video, and please write your comments, questions if you have any, and see you in the next video. Goodbye.